Hello, I'm Lynn Bondurant, and welcome once again to our series about America's civilian efforts in air and space during a quarter century. During this 10th episode, we cover 1977 and 1978. To put 1977 into historical perspective, that's the year scientists find a new life form which digests carbon dioxide and makes the gas methane. These life forms are different from plants, animals, and bacteria. During 1977, NASA's spacecraft continue on their journeys towards the planets.
In space science, two unmanned Voyager spacecraft like this are now on their way toward the planets Jupiter and Saturn. Their journey could last over a decade, with investigations of more than a dozen major planetary bodies, including Uranus. The program is designed to yield valuable new information about the origins of the solar system and formation of the Earth. One of the ways it will do this is with pictures. Dr. Bradford A. Smith is Associate Professor of Planetary Sciences at the University of Arizona and team leader of the imaging experiment on Voyager.
We begin our observations of both Jupiter and Saturn approximately 100 days before we arrive at the planets themselves. During that period of time, we're constantly looking at the planets. Each planet, both Jupiter and Saturn, rotates in approximately 10 hours. So every 10 hours, as we're approaching these planets, over that 100-day period, we will see the whole surface of the planet rotating beneath us. As we get closer and closer, the resolution gets higher. We see smaller and smaller features. And as we get very close, we finally get so close that we can't see. We don't have enough pictures to cover the entire surface of the planet. But we will select out particular features of great interest observed during that so-called observatory phase, and these features will be targeted for close examination as we fly by.
The Voyagers are to leave the solar system. Each carries a cosmic greeting card in the form of a gold-coated copper disc. Called Sounds of Earth, they are assembled by a group of prominent scientists and educators. The record begins with 115 photographs and diagrams in analog form that describe mathematics, chemistry, geology, and biology of Earth and our location. The pictures are followed by greetings in 60 languages, sounds of weather, birds, other animals, and almost 90 minutes of music from around the world. Finally, here in part is the text of a printed message from the President of the United Nations on the chance that someone is out there. This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe. And in 1977, NASA continues development of Space Shuttle.
Enterprise, Houston. Go ahead, Bevo. We have a couple of updates to your pre-flight Q card, the altitudes. Okay, stand by one. Okay, we're ready to copy. Separation is at 23.0. Next one, 18.0. Rolled out on final at 8.3. And then 1.9er.
I suggest you go ahead and start your engines and begin your taxi.
It's called Enterprise, first of the Space Shuttle Orbiters, the beginning of a new space transportation system. A craft that can carry up to 65,000 pounds into space and land back on Earth like an airplane. 5 times, 2 astronauts were carried piggyback atop this 747 jet and released. 5 times, they brought the huge spaceship in for powerless landings.
Okay, the gear is coming down at 270. Gear coming. Doors open and they're all down, coming down. Look down here. 50 feet. 40 feet. 30. 20. 15. 10. Holding 10. 220 about 5 feet.
Summing up the year's work for all 4 of the astronaut crewmen, astronaut Gordon Fullerton.
We're at the end of the approach and landing test phase of this program, but it's really not an end, it's a beginning. It's just a small step really accomplished toward getting the orbiter into space, and in that aspect, I'm looking forward to more of the same exciting times as we continue on toward that first orbital flight.
Enterprise will not be the first shuttle into space, but this one will be. Shown here being assembled by Rockwell International, it is simply designated Orbiter 102. Also completed this year, the 154-foot-long, 27.5-foot-wide external fuel tank for the shuttle. Designed and assembled by Martin Marietta at NASA's Michoud Assembly Facility near New Orleans, the external tank will fuel shuttle's 3 main engines on the way to orbit. Another major milestone for the new space transportation system was the successful test firing of one of the 2 Thiokol solid rocket motors that will also help boost the shuttle orbiter into space. This animation shows how they work during launch. The 2 solid rocket boosters strapped to each side carry their own propellants and burn for about 2 minutes before separating. Their onboard parachutes will then bring them back to Earth for recovery and reuse. The large external fuel tank continues feeding the shuttle engines for an additional 6 minutes, separating just before the shuttle reaches orbit. This is the only part of the shuttle system that will not be used again. When NASA announced it was recruiting between 30 and 40 new astronauts, more than 8,000 hopeful candidates responded, including over 1,500 women. The Johnson Space Center in Houston is in the final screening process to select from this group both mission specialists and pilots for future space shuttle flights. To get a feel for handling large structures in space, engineers at the Marshall Space Flight Center have been practicing underwater, the closest you can come for long periods of time to simulating the weightlessness of space. It's anticipated that the shuttle will make the building of large space structures possible, as well as the assembly of heavier satellites and instruments to better observe Earth and provide improved communications. Even solar satellites could be constructed to beam the sun's energy to Earth if it becomes an economic and reasonable alternative to some of our ground-based energy resources. Manufacture of the first flight unit has begun on Space Lab, shown here in mock-up. Space Lab is unique because it represents a cooperative venture by NASA and the European Space Agency. To be built in self-contained modules, the Space Lab will be placed inside the shuttle payload section. There, from 1 to 4 payload specialists will attend to a variety of experiments while working in a shirt-sleeve environment. Space Lab is expected to make significant contributions to science, medicine, industrial processing, and other fields. How stars produce the energy that makes them burn so bright, and then how they transmit this energy through millions of miles of space, losing very little intensity along the way, is of great interest to scientists. To study the stars, HEO-1, High Energy Astronomy Observatory, was launched in August. Already, HEO's instruments have found a gigantic star whose X-ray radiation increases violently over a period of time, then returns to normal. HEO-1 will be joined in its task of mapping the sky for X-ray sources by 2 other observatories in the future. NASA continued applying the technology and science learned in space to improve systems for managing the Earth and managing our business here on the ground. This includes further use of our remote sensing capabilities, which enable us to look at the whole Earth, or large regions of the Earth, in ways not previously possible. Landsat satellites 1 and 2, for instance, are helping us understand the condition of agricultural crops, forests, and groundwater, observations that make it possible to predict and manage more efficiently. Most of NASA's launches this year were paid for by other users in other countries. These included launches for the European Space Agency, Japan, Indonesia, and Italy. Not all the launches were successful, however. Both a Delta and an Atlas rocket failed shortly after liftoff, the first unsuccessful launch in 3 years for the Delta and since 1975 for the Atlas. More and more, NASA is working with other government agencies, such as the Department of Energy. NASA's understanding of rotating machinery, solar cells, and heat transfer is being applied to the development of windmills and better turbines. The Lewis Research Center in Cleveland, for example, is gathering information on as many electric vehicles as possible and is also working to improve nickel-zinc batteries. NASA is also applying solar energy technology to new developments that may bring it into effective use as part of the National Energy Program. Efforts to apply technology to make aviation safer, more economical, cleaner, and quieter continued this year at several NASA field centers. Energy efficiency to curb airplane fuel consumption has high priority. Areas of study include engine research, improved shapes, computerized flight control systems, and lighter, stronger aircraft structures. These crash tests at the Langley Research Center are an attempt to find out what happens when a general aviation airplane does just that. The highly instrumented plane and dummies should help aircraft manufacturers build even safer airplanes in the future. These spin tests look at a different safety problem, the problem of spins and stalls in general aviation airplanes. In part of the project, researchers are trying to determine the effects of tail design on spin characteristics. A new research aircraft, which combines features of both helicopters and conventional airplanes, the XV-15 tiltrotor, completed its first phase of flight testing. These short and vertical takeoff and landing aircraft may one day improve intra-city transportation. (1977), an important year for both aeronautics and space research, with much of the technology finding down-to-earth uses.
Those are some of the NASA highlights of 1977. The following year, 1978, is a significant year in the history of science. 1978 is the year the first test tube baby is born. And in 1978, no new cases of smallpox are reported in the world. Meanwhile, NASA work progresses in 1978.
It was a year of preparation, especially for the reusable space shuttle. Astronomers were able to point an orbiting telescope at stars while aiming and making corrections much like ground-based observatories. Pioneer spacecraft arrived at Venus and landed on that planet's shrouded surface. The Voyagers continued their journey toward Jupiter and Saturn. With the Department of Energy, NASA built a wind generator for a small New Mexico town. And in aeronautics, a wide range of research projects to improve both general and commercial aviation. 47-year-old John Young, veteran of 2 Gemini and 2 Apollo space flights, will be commander for the first manned shuttle mission. Here, he practices making landings in a space shuttle simulator at the Johnson Space Center with Robert Crippen, the 40-year-old astronaut who will fly with Young as pilot. Anticipating the space shuttle's flight schedule in the years ahead, NASA selected 35 new candidate astronauts in 1978 to begin training as shuttle mission specialists and pilots. The 35, including 6 women, were chosen from nearly 8,000 applicants and will be training until mid-1980. Enterprise was flown in its now familiar plane-on-plane berth from California to NASA's Marshall Space Flight Center in Huntsville, Alabama. For the first time, all the major components of the Space Shuttle transportation system came together for testing. When completely assembled, the shuttle orbiter will sit astride 2 recoverable solid rockets and atop a giant external fuel tank. The entire system was subjected to vibrations similar to those that will occur at launch. At the Thiokol Corporation facility in Utah, a shuttle booster that will produce about 2.65 million pounds of thrust at launch was successfully test-fired again. Each of the Space Shuttle's 3 main engines that will provide the orbiter with its primary power from launch pad almost to Earth orbit were also successfully tested. Work is continuing on the 2nd shuttle orbiter at the Rockwell plant in California. This is the spacecraft that will actually make the first flight with astronauts Young and Crippen at the controls. Looking farther ahead, Marshall Space Flight Center engineers have been studying problems that astronauts may face during future shuttle missions, and they are doing it underwater. This is one of the few ways that near weightless maneuvers can be practiced here on Earth. 1978 was a very busy year for space science. One of the most ambitious missions involved 2 Pioneer spacecraft that were launched toward a rendezvous and landing on this planet, Venus. Scientists believe that by studying the weather of Venus, they can learn about our weather here on Earth. The Pioneer orbiter spacecraft is programmed to circle Venus every 24 hours, studying the upper fringes of the Venusian atmosphere as it travels along. The second spacecraft, the multiprobe, is made up of a space bus with 4 data-gathering spheres that plunge down simultaneously to different parts of Venus, returning valuable information about its 900-degree surface and carbon dioxide environment. This is a computer representation of the atmosphere of Jupiter. 2 unmanned Voyager spacecraft are en route to Jupiter now. The first Voyager will reach the planet in March 1979, followed by the second spacecraft 4 months later. Then, on to Saturn. At the time of closest encounter, on November 12, 1980, Voyager 1 will have traveled 1.4 billion miles through space. The Voyager missions make it possible for scientists to go back in time and sample the conditions from which the Sun and planets, including the Earth, are believed to have formed. IUE, International Ultraviolet Explorer, is a telescope in space which is operated effectively in real time by astronomers on the ground. Visiting astronomers at the Goddard Space Flight Center can have the telescope pointed, decide what data to take, and modify their measurements as they observe. With craft like IUE, scientists can begin thinking in terms of observatories in space as facilities. Also launched in 1978, the second in a series of high-energy astronomy observatories, HEO-2, The 7,000-pound spacecraft carries a large X-ray telescope with 4 major experiments which can be pointed at specific objects to study them in detail. The high-energy explorers are giving astronomers a different view of our universe and helping us to better understand it. The Space Telescope moved through another manufacturing phase this year at the Corning Glass Works in upstate New York and is scheduled for deployment by the shuttle orbiter in 1983. Looking from space with instruments in space, we can see the universe in ways that are impossible from the ground, bringing us closer to even greater discoveries in cosmic astronomy. There was continued and increased emphasis on applications in 1978. Landsat 3, a remote sensing spacecraft, was orbited. Efforts like these over the next decade will try to develop a capability to watch and understand what's happening on the surface of the Earth, land and water, and to put all that data together in such a way that it can be used as management information for the global environment. Before its so far unexplained short circuit, the first CSAT collected data for 99 days. What it returned during that time were images of sea ice, waves, coastal conditions, and various landforms. It also measured sea surface wind speeds and temperatures. Project scientists expect it will take more than a year and a half to process the data collected by CSAT. This is Beth, a perfectly healthy child of a NASA employee at the Johnson Space Center in Houston, Texas. She is shown here testing out the fit and mobility of an isolation suit that can be used by a youngster with a rare disorder known as severe combined immune deficiency disease. Because of his inability to fight off even the most common germs, 7-year-old David has had to be confined in sterile isolation since birth. The NASA-developed isolation suit now allows David to get out and at least do some of the things normal children enjoy. Ben Abruzzo and Maxie Anderson, 2 of the 3 men that crossed the Atlantic using a helium-filled balloon, stopped by the Goddard Space Flight Center to meet some of the people who monitored their flight with the help of the Nimbus 6 satellite. On their first attempt, the Nimbus 6 beacon made it possible to alert air-sea rescue when they became lost in a heavy storm. So for the second try, Ben Abruzzo said they decided to take along an extra beacon.
On the second flight, because of the fact that we knew that the only link we had with the world on the first flight was the satellite transmitter, we had 2. And again, the information came to us in flight telling us of our course and our position. It confirmed the weather data that our base station had and allowed us to change altitude properly so that we were able to complete the flight successfully. And in fact, on the tail end of it, we changed altitudes and vectored ourselves onto a very close destination proximity of Paris.
Last January, the first large operational wind generator to be used in the United States in several decades began producing electricity. The place? Clayton, New Mexico. Population about 2,900. The project is funded by the Department of Energy and managed by NASA's Lewis Research Center in Cleveland. The 100-foot-high wind generator is capable of producing 200 kilowatts that feed directly into Clayton's utility system, about enough to electrify 60 homes. The research is aimed at improving performance and helping determine the future cost of electric power generated by wind systems. In aeronautics, the emphasis is on basic research and basic technology, preparing the way for future advances in aviation. At the same time, NASA continues to develop technologies to the point where industry can take them up. One of the major research efforts involves using full-scale wind tunnels and other facilities to improve crop dusting aircraft. Studies of how spraying is affected in the wake behind the airplane, handling qualities, fuel efficiency, and overall airplane performance are the goals. See those vertical fins on the wingtips of this small business jet? Those are called winglets, and they were invented by Dr. Richard T. Whitcomb of NASA's Langley Research Center. What the winglets do is reduce the drag on the plane as it moves through the air, saving fuel in the process. Just about any plane can benefit, from the largest jet cargo tankers to small cross-country planes like this one made for the home-built market. Again and again, engineering research pilot Jim Patton forces his single-engine plane into a stall spin. What he and the data-gathering engineers on the ground are trying to do is improve the design for wings and tail sections of airplanes to make them more resistant to stall spins. This type problem accounts for about 30% of crash fatalities in small private airplanes. Combinations of wind tunnels, simulators, radio-controlled model flights, and full-scale tests are used to gather the needed data. There were two anniversaries in 1978 that need to be noted. 75 years ago, Orville and Wilbur Wright made the first successful powered flight in an airplane. It was also just 20 years ago that the space program officially began, an extension of the basic Wright brothers flight. 1978, a year of progress in both aeronautics and space research.
And those are NASA film clips from 1978. Please join us next time when we cover NASA's progress in the years 1979 and 1980. I'm Lynn Bondurant.
Looking good. Roger, Columbia on a roll. Columbia, Houston, your go at 40. Roger, go at 40.